Till now, whatever we discussed about regression, this regression line is known as simple linear regression line. It's known as simple regression. Why it is known as simple regression? Because there is only one predictor variable, y equal to beta naught plus beta 1 x. That's it. There is only one x. To predict the number of passengers, we are simply using only one variable, that is promotional budget. But in real life, that is not the scenario. It's not just one variable that impacts our overall target. There are multiple variables together impact our target. It's not just the airfare. Maybe there are several other variables that will together impact the overall target variable. That's why we need to build something called multiple regression model. It's all the same. The whole theory remains the same. Just that instead of using one variable, that is x, x1, we are using multiple variables x2, x3, x4, x5. Earlier we were building one line, regression line, in a two-dimensional plane. If it is like having x1 and x2, it will be a kind of plane in this three-dimensional system. So simply we are using multiple predictor variables instead of single variable. That's the only change. Remaining everything remains the same. Your R-square interpretation will be the same, everything else will be the same. We'll have a beta naught value and then beta 1, which is coefficient of x1, beta 2 coefficient of x2, beta 3 coefficient of x3, like that. So build a multiple regression model to predict the number of passengers. So what we'll try to do is we'll try to predict number of passengers using promotional budget, intermetro flight ratio, service quality score. There are several variables, right? So there is this service quality score, promotional budget, intermetro flight ratio, etc. So we'll use all of them to actually predict the number of passengers. So let us see. So we are building a multi-model. We just need to use LM function. Passengers, we are still predicting passengers only, but not using one variable. We are using three variables to predict from the dataset air. So here is the code, we write it. And then look at the summary. Is there any improvement? So this is the coefficients of, this is the intercept beta naught, beta 1 x1, beta 2 is this one, beta 3. So what is the R square value? Around 95%. So there is a slight increment in R square by adding these two variables. Sometimes adding multiple variables might increase the R square value. So this is the summary of the data. So instead of building one model, instead of building a model with single independent variable or single predictor variable, we are using multiple predictor variables for prediction. That is called multiple regression model. Now, individual impact of the variables in this multiple regression model. It is not a rule that if you keep on adding the variables, it will be of some sense or it will make some impact on the data or on the model. There is no rule that if you keep on adding the predictor variables, you will see a better model. No. Sometimes we don't know what variables are impacting our passengers, what variables are impacting the target, what variables are not impacting the target. So in a given regression model, let us suppose you built a regression model Y using 10 predictor variables. How do you know that what are the most impactful variables from those 10? Or how do you know that what are the variables that can be simply dropped? They have no impact on the model or they have no impact on the target. There is no use of using those variables. So we can simply drop those variables from the model. But how do we know the individual impact of the variables? So there is a lot of theory to find out the individual impact. Finally, this theory boils down to something called p-value. A variable is having a significant impact if the p-value of that variable is less than 5%. If the p-value of a given variable is less than 5%, then that is an impactful variable. That variable should be kept in the model. If the p-value is more than 5%, then that variable has no impact. There is no point in keeping that variable. We can even drop that variable. There will be no change in R square value. or R square will be impacted insignificantly. There will be no real big significant impact on R square. So a variable is not related. Let us suppose if you are trying to model something called laptop sales, there is no point in taking the number of cosmetics that were sold, or then a simple example is if you are trying to predict laptop sales, there is no point in considering number of street dogs. So how can you use to predict laptop sales using number of street dogs? No, right? But if you still keep that in the model, then how do you find out that whether that variable has impact or not? You need to look at something called p-value of that particular variable. So for every variable in the summary, we can see p-value, that the probability value, that is result of a t-test. So you just need to see summary of the model that you just built. In that, here is the p-value or the probability value, probability greater than t. So simply you just need to see the variable number 1, is it less than 5%? Yes, it is less than 5%, so this is highly impactful. So promotional budget is highly impactful. Intermeter of light ratio, is it less than 5%? No, it is 35%, so that has no impact. Keeping it or dropping it is not going to make any change. Service quality score, is it impactful? Yes, it is impactful, because it is less than 5%. So out of these three variables, we can simply drop intermeter of light ratio, because that is having no impact. So we can rebuild the model by dropping the, we can rebuild the same model by simply dropping that particular variable. So here is the model. So what we'll do is, model 1 will try to build. So individual impact, let us see impact of variables. I'll try to rebuild the model and I'll drop intermeter of light ratio. Why am I dropping the intermeter of light ratio here? Because if you see the summary of previous model, it is having less than 5% p-value. So we are going to simply drop that, and then I'm going to rename this as model 1. So we also need to write dropped intermeter of light ratio variable due to high p-value, right? So let's rebuild the model. Model 1, summary of model 1. You can see that R square is almost near that only. Now promotional budget is also having high impact, service quality score is also having high impact. So that is the use of, or that is how we measure the impact of the variable. In fact, we can prove this some other way also, impact of the variable. What I'll do now is, in this model, I already know that promotional budget is highly impactful variable. What if I drop that high impacting variable? Let's try to understand what I'm saying. What if we drop a high impacting variable? That means we are going to lose the prediction power. That means the model is not going to be as good as this, because you are dropping an impactful variable that is going to impact a lot the target variable. But still we will go ahead and drop it. So I'll drop the promotional budget. What are you expecting? You will expect a huge drop in your R square value, because you are dropped promotional budget just to check. Okay, simply we do that. What is the new R square value? 78%. From 95 to 78 we got, because what's the mistake that we did? We dropped a high impactful variable. If you drop a low impact variable, if you drop a variable that is not related, nothing happens to the model. If you drop a high impactful variable, your R square value will reduce. So that is how we see the individual impact of the variables, looking at the p-value.